Hello everyone. Today we will discuss on resolution of force into two components, two-dimensional way. In engineering, mechanics, and physics, force often act angles rather purely horizontal or vertical direction. To analyze such forces effectively, we resolve forces into its component along the coordinate axis, usually x and y axes. So this process actually simplifies calculation involving equilibrium, motion, and structural analysis. Myself, dranimaghosh, Associate Professor of Physics at SR University, Warangal. So let's begin. So first is what is the mean of resolution of a force. So resolutions of force is the process to splitting a single force into two perpendicular direction that have same effect at the original force. So in two-dimensional analysis, basically one component along with the x direction. So one is basically x direction and another is in y direction, and the x direction is basically it says as x direction, that is generally write as horizontal component. So x direction, that is horizontal, that is x direction one, and the vertical part is in y direction. So for that, first to consider a force acting at an angle theta. So here this force F, that is acting with the x direction and angle theta. So x direction component is it is representing xi along with the unit vector I, and y direction it is j, that is the unit vector, and y is the component in y or in vertical part. So the force can be from this now it is forming a triangle. So from this triangle the force can be resolved as that is f x, that is basically f cos theta, and f y, that is f sin theta. So this fx is the horizontal component, this x is horizontal component, and this y is the vertical component. So the question is here that why we do need this resolve forces. We resolve forces because the equilibrium equations are written along x and y direction. Motion equations are easier in perpendicular direction, and structural analysis requires component wise calculation. So to see the equilibrium equation, their motions and structural analysis, it is important the analysis of in two component. So in 2D equilibrium, basically that summation of the force Fx, that is equal to 0, and for y summation of Fy, that will be again 0. So now we will do that how we can do step by step this, that how we can resolve it and how you can component wise split it. So draw first the fixed force vector, like here representing by F, then draw the x and y axis, then I need to identify the angle, and then need to complete a it will complete a triangle. So from this triangle the trigonometry adjacent sides we can write as this is f, this is xi and yj. So adjacent side will be f cos theta and another is f sine theta. So one can write this, then f is equal to f cos theta I plus f sine theta j. So also we can find out this from this one, that magnitude is this is equal to is basically x square plus y square. So it we can write as that if that magnitude that is equal to fx square plus fy square. So now let us solve one problem that here let's consider the two forces, F1 and F2. This is F1 and this is F2, which have the magnitude of F1 is equal to 17 Newton, and F2 is equal to 9 Newton. So acting on a particle as shown in this diagram, what is the magnitude and the direction of resultant force F? So here we can write for individual forces that for F1, what is F sine, means Fx and Fy. So we can write for the force F1, that will be 17 cos 27 degree plus 17 sine 27 degree j. It is given that angle is here in 27. So same thing we can do it for F2, that will be minus 9 cos 54 I plus 9 sine 54 degree j. So now we have this F1x is this and F2x is this. So total we can find out the total Fx component of F1 plus F2, and similarly F1y plus F2y. If so, we can find out the resultant, that is basically the F is equal to F1 plus F2. So if we add all our component which we have derived, then we can get it that F1 is basically we will be getting it 9.85 I plus 14.99 J. Now we can find out the magnitude. That square root of Fx square plus Fy square. So if we do this one, then we can find out that it is basically the 9.87 square plus 14.99 square. So this will be closely equal to 18 Newton. And now we can find out the angle theta also, that we know that tan theta is basically this y by x. So this is our y component, this is your x component. So it will be theta equal to tan inverse 14.99 divided by 9.85. So this is closely equal to 56.68 degree. So this 56 point it is closely equal to 57. So you can see that this is just above of the x-axis. So this is the way how one can find out the component or resultant force of multiple force acting in different angle. So just with some bit more complex, with considering one more forces, we consider another example that here we are considering the three forces acting in three different angles. That this one force is acting with this 25 Newton with angle 10 degree, and that is 40 Newton with angle of 80 degree, and third one is 15 Newton with 45 degree. So here also the process is same, that when the three or several force involved, it is sometimes easier immediately that collect all I component, then collect all j component. So that is resolve horizontally, then vertically. So if we resolve it in horizontally, that horizontal component, so horizontally our value will be here that 25 cos of 10 minus 40 cos of 80 minus 15 cos of 45 degree. So if we get this, we will get 7.068. Similarly, for the, if we resolve the vertical one, one can get is the this 40 sine of 80 degree. Here the rest of part, that means 40, you can find out from, start from here, that sine of 80 degree minus 15, this second one, the 15 of sine 45 degree minus 25 sine of 10 degree. So if we solve this one, we can find out 24.445. So therefore the resultant force, we can find out that this is our total horizontal component and this is the vertical component. So we can find out the resultant force magnitude. So magnitude, we can get it that basically 7.068 square plus 24.445 square. So this is basically equal to 54.45. Similarly, we can find out the angle resultant angle theta, that is tan inverse y component, that is 24.445, that is approximately 24.45 divided by 7.068. So this equal to 74 degree. So above positive x-axis. So this is how we can find out, this is how we can find out the two-dimensional resolution of the force. And yeah, this is resolving the force into component is the very fundamental concept in engineering mechanics. It allows complex angle forces to simplify, to find out, to know or to understand the statistic, dynamic, structural engineering and mechanical system analyze. So thank you very much for watching the video. Please like on the please click on the like button if you like the video. Thank you.